Mute.
Okay, my slides are visible.
Yes, sir. Make it the slides were visible, but make it in the present.
Now,
Yes, sir. Visible.
okay, fine. So we can start our this lab session, right? Okay, okay, participant. Very good afternoon. Uh, so as we are moving forward in this our FDP programs, which is based on smart manufacturing and industry 4.0 solutions. In morning session, we have seen there are some lectures which are based on smart manufacturing and related to industry 4.0. So on behalf of that, this lab session will be depend upon the smart manufacturing and it is related to its application. So in this session, we will discuss about the application of artificial neural network in smart manufacturing, which is one of the most promising areas where artificial intelligence is revolutionizing the manufacturing world. By the end of this lecture, you will understand what are the INN, how they work, how they can apply to solve the real world manufacturing problems. So we will perform this ANN code on Google Colab. So if you want to perform with simultaneously, you can also perform with me. I will go through step by step, so you can perform the coding session with me also. If you are having any doubt during the session, you can raise your queries in the chat box. I will see in the meantime and reply or provide you the those the required answers. Okay, fine. We will move forward. So this is the table of content we will cover during this session. First, we will introduce about the artificial neural network, what are the data set and how we will pre-process. Uh, we will build a simple artificial neural network model. Uh, Afterwards, we will cover the training and evaluation session, how to network learns, how we can check its performance. Simultaneously, we hands-on extension means I will provide you the code as well as I will code during the session, so you can see, learn, and you can also practice simultaneously on the same platform. At the end, we can discuss and wrap up. So, as we move towards the smart manufacturing, as in the earlier sessions and in the morning session, smart manufacturing already discussed. But here we are also discovering this. What is the smart manufacturing? So it is a data-driven, connected, and automated production process, whereas machines, sensors, and softwares work together to monitor, analyze, or improve the manufacturing in the real-time application to make it more efficient and flexible with predictable also. It's better to understand the smart manufacturing. We go through with a simple example. Let's start with uh, a simple example, like a CNC producing, which is making car parts. If we see in the traditional approach, an operator check the quality at the end of the shift. If he found there are some errors or there are some variables which are need to be adjusted, so he adjusts the machine settings manually if there is some requirement need to be done. But in case of smart manufacturing, sensors are already attached on the chassis, which continuously measures the vibration and tool wear during the machining, during the processing. So already or the ANN models which are already pre-existing modeled. So sensors give the data to these NNN models, which predict on behalf of the data uh, captured from the sensors. When the tool is about to fail, automatically adjust the variables in such a way they can adjust the cutting speed or alert the operator so that they can prevent the defect before the happen. So this is the way smartness in the manufacturing can be performed. So what are the tools which make the manufacturing smart? So in that case, CNC sensors, vision systems, MES, ERP, quality inspection, and etc. These are the tools by using which we can make the manufacturing as a smart. So in that case, these systems and making the huge amount of data in every second. So this data we have to analyze if we want to perform or if we want to take any action to this data. So to make manufacturing truly smart, we need to convert this data into, first of all, we see the inside, let's say defects which are happening in the plant. So why these defects are happening? On behalf of that, we need to make the predictions. Means when will a machine fail? On afterwards, we have to prescriptions which parameters should we need to be changed to improve the yield. So the defect should not be occur during the process, and we can make the prediction before the machine fail. And in during this thing, what are the parameters that are play a key role? So we can change these parameters. But as we know, in smart manufacturing process, there is a huge amount of data has been captured. So with the traditional statistical models, they are not able to process a huge amount of data simultaneously. If there are some non-linear problems are occurred during the process, such as well temperature versus strength, this is the non-linear. So traditional model which are often fail during the performing these kind of models. Also, they are not able to interact multiple variable at a time. If the speed, force, temperature, or tool geometry, these are some variables which are simultaneously interacting each other. So traditional statistical tool often fail. So in that case, what we require? We require some models which play a key role during the processing of this data. So artificial neural network play a key role in processing of this data. It can learn complex or non-linear relationship directly from data. It also adapt new data by improving over time. Means it retrain and adapt the new data. They run fast enough to real-time prediction and control on the shop floor or whereas it is applied. So we need to be know what is the artificial neural network. Artificial neural networks are computational based models which are inspired by human brain. Here you can see the symmetric representation of brain neural structure and on behalf of that artificial neural structure also. So in our brain, which is made of billions of tiny cells, that is called neurons. Each neuron takes signals from other neurons like little messages. It processes the signal and then decide whether to pass it on the next neurons. If it is need to be passed on the next neuron, it is passed. It have to take some action. So it process at that the neuron level and further it process to the next neuron. When many neurons work together, they allow us to see, think, learn, and make decisions. So this is the way by doing which our brain works. Similarly, in artificial neural structure, which is computer model, instead of real neurons, here we are using artificial neurons, we can also say that nodes. Each node takes input in terms of images, in terms of data. So input has been taken from the nodes. The input further processed with the mathematical parts and decide whether it to pass forward direction by application of some activation function. Many nodes connected together in layer allow to ANN to find patterns or make decisions. In when we are processing the data, we need to be identify first what are the patterns there. If there are some patterns found in the data, so artificial neural network decide which kind of patterns has been found in the data, and on behalf of that, it make the model in such a way that it can further take action according to the history of the data. So by doing this, ANN is able to make decision just like our brains learn from experience and make the decisions. So on the neuron level, what is the activities has been done? Like each neuron receive input data in way of signals, which here we are denoted in the x's, like x1 input, x2. There are number of inputs on the single nodes. So that is denoted in xi. These initially these inputs are multiplied with the some weight. Initially, the weight are initialized with each input. In further process, when the model adapt by itself or when it learns through the processing, so these weight are adjusted according to the learning process. So these weights inputs are summed and combined with a bias term. This input is then passes through the activation function to produce the output in Y. So this is the basic structure of artificial neural network. In that we can see here input layer, hidden layer, and output layer. In input layer, as we discussed, it takes the input data which in terms of process parameters or sensor data. We know sensors in the CNC machine, it provide the vibrations data, force data. These are the data has been sensor captured and provide to the uh, model where we need to be read the what kind of data, and on behalf of that we will perform the further process. So in input layer, process parameter or sensors data has been captured. In hidden layer, the important thing is that hidden layer perform the mathematical transformations, discovers pattern, and learn relationships. What are the relationships which are observed in the data? So these are the things will be performed over the hidden layer. And what is the output layer? Output layer produce the final results, which in terms of predicted hardness, defect probability, which may be terms of other characterization other characterization responses. So what are the requirement of our responses? On behalf of that, it predict the final output. So as we discussed the hidden layer, so we need to know about how the artificial neural network learns and how the mathematical transformation takes place in the hidden layer. So on behalf of that, we need to understand what is the learning process in the artificial neural network. So the learning process in ANN involves two main stages. One is forward propagation and another is back propagation. As we see in this diagram, schematic diagram, in which you can see here, this is the feed forward. First, the data is comes over the input. This is processed in the hidden layer and comes out in at the output. So once the output is observed, we will check with the actual value. If there are some difference between the output and the actual value of the predicted values, there are some difference, so it is back propagate and revise the multiple things in which weight is the major one. So the learning process in feed forward propagation, data flow from input layer through the hidden layer to the output layer where predictions are generated. Each neuron in a layer computes a weighted sum of its input. As we have discussed, we have multiplied each data with weighted, and afterwards we weighted sum of the input, added a bias term, and applied with an activation function to introduce non-linearity. The resulting output of one layer served as input to the next. The predicted results are compared with the actual experiment data using a loss function. The loss function, which is mean squared error. If we are doing the regression task, there are multiple problems we can solve through the artificial neural network. But we will talk about the regression problem. In that case, we are using mean squared error. So by doing this, we can check the predicted value and actual value. If there are some error found, we will process it further. In backpropagation, backpropagation is then utilized to minimize the loss function. This loss function is denoted by mean square error that is captured through the regression. So the backpropagation is then used to minimize the loss function by computing the gradient of error with respect to the network's weight and biases. These gradients are used to update the parameter through optimization algorithms such as stochastic gradient descent, or we can say that ADAM. The general update rule is expected the new weight is identified as the old weight with the differentiate with weight, or we can uh, differentiate this grade. We take this gradient of the loss function with the terms of weight as well as the bias. So alpha is the learning rate which determines the step size of the update. If the higher learning rate, then shorten the training time but may reduce the model accuracy. So we need to be adjust this learning rate also. If we choose the low learning rate, increases training stability at the cost of the longer convergence time. So we need to be optimize this learning rate also. Each complete cycle of forward and back propagation over the training data set is referred to an epoch, and training continues until the loss converges to a minimum value. We will see in the further when we execute this code, we will see the what are the epochs, what is the convergence, what is the learning rate. Okay, so these are the basic terminology which we will use during the coding also. As we are discussing about the activation function, so what are the activation function? So each neurons in the hidden layer compute a weighted sum of its input, which then pass through an activation function. The work of the activation function is enable the network to learn complex patterns between the input parameter and output. In activation functions, there are few functions are available in which sigmoid function. This is used for binary classification problem, but it is suffered from vanishing gradient issues. So this is the function of sigmoid. Another one is ReLU, rectified linear unit, most commonly viewed in hidden layer, enables faster convergence. When we require the faster convergence, we use ReLU. Hyperbolic tangent is centered at zero, used in some architectures, or linear activation used in output layer. This activation function is used in outer layer for regression problems, predicting continuous values like strength or hardness. Sorry. Now, after the learning or activation, we need to be train our model. So the training will take care to improve the generalization ability of network and prevent overfitting. Regularization techniques such as dropout were implemented, wherein a fraction of neurons is randomly deactivated during the training. Means once we are using or we perform the model of ANN, sometimes it may be overfitted. So we are using the dropout. Why we are using the dropout, which will use the friction of neurons. So the overfitting problem may be reduced. So this approach reduces the dependency of specific neuron and enhance robustness. Model which were formulated, which also be which also be have been evaluated. So how we are evaluated our model? So model performance was assessed using the evaluation matrices, including the coefficient of determination, R square. We check the R square value, mean absolute error, mean squared error. In that, R square score can be given by this formula. This measures a proportion of variance in dependent variable that is predictable from independent variable, which with values close to zero indicated strong predictive accuracy. So this is the flow chart how we will perform the artificial neural network on the data. So first of all, with the start of the artificial neural network, we have to be identify the input-output response. Once we identify the input-output response, we extract the experimental data. In terms of, we can extract the data in terms of Excel file or in terms of other files which can be executed through the model. Once the data has been extracted, this needs to be normalized. So the data, if the normalized, which will be range in 0 to 1. Afterwards, we will personalize, we will make the data into 3 sets, in which first we will provide data to train the model. Once the model is trained, the further data which used for test the model, and once that model has been tested, then we will validate the model by using the data. In that way, we need to be select the hidden layer and activation function. Once we need to decide the model, so in that model we need to be identify how many number of hidden layers we need to be required and which activation function, as we are using the regression model. So once we are doing the regression analysis, in that case the number of hidden layer will be different and activation function will be different. So on behalf of the what are the problems we are going to be solved, we need to be identify the according to the hidden layer as well as the activation function. By varying the number of neurons in hidden layer and selecting the selection of the training algorithm. So why we are doing this? First we need to be identify how much error we need, we have to decide how much error, because at the end we need to be think that our error should be as minimum as possible. So on behalf of that we need to be put the number of neuron in the hidden layer. Once the model is trained, once the model is trained on behalf of the number of hidden layer, activation function, neurons, then we will test and validate the network. And once the model is tested, the NN model ready for further evaluation process. Now, where we can perform the artificial neural network? So there are several options are available through which we can perform the artificial neural network, in which we can use the Python based tools, MATLAB, software, programming, cloud platforms, GUI based tools. There are several platforms over which we can perform the artificial neural network. So in this lab session, we will use Python based tool. So Python based method, here is also we can perform the Python coding in TensorFlow, Keras, PyTorch, Scikit Learning, Jupyter Notebook or Google Colab. Here we are using the Google Colab because this is the cloud-based and free to use. So during this session, you are able to also perform the code by using the Google Colab. There is no need to be download any software. You just click on the Google and just write the Google Colab. You can access the Google Colab directly. There is no need to be install anything. Also, there is the TensorFlow, PyChart, or scikit learning we can use without installing anything. So that's why for this this lab section, we are using the Google Colab to understand how we can implement a simple artificial neural network problem. So what are the type of problem? As we discussed, the artificial neural network can solve the classification based problem, regression based, pattern recognition, optimization, control and automation, prediction and forecasting. In this lab session, we will perform the regression problem, which will also can be used to predict the which is also can be used for the prediction also. So regression for the yield, no, we will which regression program we are going to use in this session. So first I want to clear you this is the schematic of friction shear process. The friction shear process modify the structure of the base material surface. In this way, friction shear process rotates over the surface and it plasticizes the material. Once it plasticizes the material, it move material from forward to backward direction. By doing this, the base structure has been sensed and the new structure which is modified through FSP, the characteristics of this modified structure has been improved. So in all this way, there are some input parameters which are involving to improve the structure. Here we are going to analyze the input parameter such as rotational speed, table speed, number of pass, or volume fraction. Actually, this program is related to modify the structure, or we can say that the surface composite fabrication by using the friction shear process. The FSP can modify the structure base material directly, or it can modify the surface by adding some reinforcement particle over the surface. But important thing is that it modify the structure by using these input parameters in which rotational speed each one is the major factor, table is also the major factor, number of passes and volume fraction. Volume fraction is related to the fraction of reinforcement which are going to be used in during the process. Here we have observed the response of that modified structure is yield distance. Now what we want by using these number of we- with varying the rotational speed, table speed or number of passes, we observe the yield strength. Now what we want if there are some number of experiments we perform, afterwards we want to predict the other which experiment we are not going to perform, but we want to observe the yield strength. So this is the kind of prediction based analysis which will be performed by ANN. This is one problem which we are going to be perform during this session, in which we are going to be predict this yield strength by using these input parameters. So now I will show you how we will perform the artificial neural network coding in the Google Colab. So if you want to perform the coding session, you can also start with typing Google Colab. Here you can see open notebook. So now I'm going to be open new notebook. So this is the interface of Google Colab. Here write that we can start with writing the code. So first of all, okay, now importing drive. Why we need to import the drive? As we see here, before starting the code, we need to be required the input output response, which in terms of data. So for data part, we need to be we in ANN we need require the data. So we can type the data, or we can add the data by manually, as well as if there are number of data, if the last file are available, so we can directly import the data over here. So by writing this code, we can directly connect our Google Colab with our drive, because this excel file this excel file is already like this excel file is already on my drive. So I directly import this excel file on my Google Colab platform. So for that we need to be write one line code. This is the 43 sets of experiment in which rotational speed, table speed, number of pass, and volume fraction. These are the sets of experiments which were performed. On behalf of that, we have identified the yield strength of the modified base material. So these are the values of yield strength, yield tensile strength of this base material after the modification. So import drive, or by doing this I can mount my drive with Google Colab. So once now this is connecting, you can see this is connecting. Once it is done, my Google, I can access my drive files over here. Now you can see here in the mounted at content drive. Okay, so my drive is mounted. Now I want to import the Excel file, this Excel file to this Google Colab platform. For that I have to be right. You can see my file, that name is ftp slash data xlsv. So I want to be take I want to import this Excel file to my Google Colab, so I can see it. You can see the header of these files as I have read here. df.dat. df means data file, which this file path I have already provided here, and this Excel file or data sheet I have mentioned it is as short form of data file. Okay. Now, if I want to see the head of this file, so this will be the simple code of, for that I can see the head of this first 5 lines of my, or first 5 row of my data. Here you can see this combination of 5 rows we can see here also. Now first we have importing file. Now we can see this is the header of the file. Next is, if I want to see or I want to know about what kind of data, so for that I need to write df.info, and it simply provides us the what information about the data file. Also it will describe, like, in the data file we have column of rotation speed, table speed, number of pass, volume, flexion, yield, tensile strength, 43, as we have described, number of 43 number of experiments or sets of experiment. For data type, the all the 4 input parameters are integers, and the yield tensile strength which is in float type. Also we can see that rotation, these data can be, as we described here, so it is also described it in terms of average, standard deviation, minimum, maximum, or 50%, 25%, 51 maximum. It will be divided in such a way. So you can see also about, you can find about your data by doing this. Now next, what is the next step? Next step is initializing the data, because we have to initialize the data in input and variables. So first we will need to initialize the data. So we keep our input parameters in X and our output parameter in Y. Now, so you can see here, if I want to see what is inside the X and what is inside the Y, so we can simply you can see these are the input parameter which is stored in the X. Or if we want to see what are the values in Y, so we can simply put Y and check, run it. These are the data set in the Y also. By doing this, you can check your data which are bifurcated into the input and output responses. Now, next step, we initialize the data. Now, next step is the normalized data, which is the important part to process any, perform any analysis. We need to be normalize the data. So, to normalize the data, we need to be form our data in such a way that it should be in the range between 0 to 1. So we need to be normalize it. This is called pre-processing. So as you can see here, this collab automatically tell us what the things we need to be right. So will automatically show us what we need to be right. So by doing this, we can directly tab and we can perform this. So by this, we normalize our data. So after the normalizing the data, we have to import the libraries for Python. Why? We need to be importing the libraries. So because the purpose of these libraries are different. Because if we talk about the TensorFlow is a library which we use to the build and train the artificial neural network. If it is not installed, the rest of code will not be run. So to make or to run or to perform the analysis, we need or we import some libraries. So for that, we have to be done in Google Colab also. For that, importance of STF, tensor, Keras model, sequential, dense, dropout for already discussed to prevent the overflow. Overfitting. Dropout is used to prevent the overfitting. Lesson split from minus by L as y SPLT also. So, importing libraries for Python. As we have discussed why we need to import these libraries for Python. So first, this line means TensorFlow. This command installed TensorFlow inside the Google Colab because we need this because this TensorFlow used to build and train artificial neural network. If it is not installed, the rest of code will be not run. Okay. So the second is TensorFlow. So import the TensorFlow library and we provide it as TF. So if in further case we will use, so we will need not to write as hold the name TensorFlow. We can use TF as a short abbreviation. So already we have discussed TensorFlow are tools for building, training, and evaluating the artificial neural network models. Now the NumPy. Why we use NumPy? We have to as we have discussed in hidden layer, the mathematical equation will take place. To evaluate these mathematical problems, the NumPy library we directly use to evaluate these mathematical model. So used for handling array mathematical equation, data manipulation before feeding to the model. That's why we are using NumPy. This sequential is used from Keras. This allows us to build a neural network from layer by layer in a simple linear stack. This is most common for beginners. As we have discussed, dense, fully connected layers, each neurons is connected to another, all neurons are another layer, all neurons. So that's why we are using here dense and dropout already discussed to overfitting. We are used to make the model should not be overfit. So we are using the dropout which prevent the overfitting by reducing some neurons by its own. Test and split already we have to be split our data into some data has to be split into the training set or some is split into the testing set or if there is required to validation test also so we can use some data for validation also. So as we know we need to train our artificial neural network model on one part of data and the test data will be checked. The model, the generated model is well according to it already like by uh, during the training or learning process it automatically analyze how the model behave. So it is used to test this data if model is captured the actual behavior of the actual behavior of the data. That's right. Now this L2 regularization function is used in well decay, adds a penalty to large weights in the network, which help to reduce overfitting and improve the generalization. Mean squared error or R squared. Once we are checking the loss to measure how far prediction from our actual value already once the training has been done. Afterwards, we will predict our output response and we will check that output response with the actual value, and this has been measured by mean squared error. R square is scored because as this is the regression, so coefficient of determination need to check shows how well the model explain variance. Why needed? So these helps quantitatively evaluate our trend model. If we want to check the check the data in the graphical manner, so this library is used to plot the data. So used to visualize trending curve, testing curve, in which we can see the loss versus epoch graph. We can see the actual versus predicted values also. Now, already we have imported the libraries at the Google Colab platform. So now we will split our data into the training data set or testing data set. So for that we need to be write this code. Okay. Extrain, because we have also splitting the data, input data as well as the output data. So extrain test, y test, train test split, x scaled, y scaled, test size zero point 0.2 or random split 42, which means you can see here test size zero point 0.2 means we split our data into 80-20 ratio, in which 80% data is used for training process and 20% data is used for testing part. X scale, which is the normalized data, which are the input features that is normalized, or Y scales are for the output or response. In this way, we will get four sets: X train, X test, X Y train, or Y test. Already discussed test size zero point 0.2 means 20% data reserved for the testing process. Once we have trained our model, afterwards we need to be tested. So during that time, 20% data will be used for testing. Random state 40 to ensure reproducibility, split every run. Means every split every run, the 80-20 ratio should be maintained. Now, the important part is the model formulation. So first we will form the model. Afterwards, I will discuss what is inside the model. Model, as we have to select it sequential. Now model. Now we will add layer by layer. So first we will use it automatically suggests us what we can choose. So according to this, we can directly choose as it is suggested, or we can modify it by ONS. For the regression problem, we are using the activation function as ReLU. For the input for the hidden layer, we can also, here we have option, we can use the multiple hidden layer also, or we can use the single hidden layer also. That is depend upon the complexity of the problem. So you have to be decide how many hidden layers you need to require in your model, or number of neurons, which will also a major important factor, which is also decided by you, or you can decide according to your data shape, or according to your the problem. Means your problem is complex, non-linear. According to that, you have to decide this data set also. This These are the uh, neurons, or these are the hidden layers you have to decide. So in this problem, I using generalized thing. If you want to change, you can change according to once you see this model, and afterwards you can do by your own. Here I am using three hidden layers. If you want to add only two hidden layers, you can add two hidden layers, but I just want to show you how these hidden layers affect in once we train our model. That's why I am initially I am using, afterwards I, if I want to reduce the hidden layer, I can directly reduce it by putting the hash in front of the each layer, front of which are the layer I want to reduce, I can reduce by using the hash in front of the layer. Now I want to put here like this is for input plus first hidden layer. This will be our first hidden layer. This is our second hidden layer, and this is our third hidden layer. In the outer layer, we are using linear as an activation function. So this is our model. You can see here. In this diagram, we have discussed we have one input layer, three hidden layers, and one output layer. In these three hidden layers, we are using 64 neurons in first hidden layer. In second hidden layer, we are using 32 neurons, and in third, 16 neurons. If these values you can change by the target value of your error, means if you want to minimize your error as much as possible, so by increasing or decreasing you need to check your error. If your error, if the number of neurons increase in hidden layer 1, if increase by increasing the number of neurons in hidden layer 1, or your error is reduced, so you can go with that. But you need to be also check for the output also. That's why after the second hidden layer, here we have provided the output dropout, which is prevent the or fitting of the problem. So this is our model. Now you can see that, okay, sequential, okay. It said that model sequential is not defined. So why we are getting this problem? Because I have write this code, but I have not initialized this, I have not run this code. That's why uh, our libraries were not imported in the Google platform. That's why when once I have write this code over here, so it is not recognized and it is not defined. That's why now you can see here. So our model has been formulated. Now we need to compile this model. So first of all, I want to show you, already we have discussed these things. Model formulation, model sequential already show it. Sequential means network built layer by layer in order, simply linear stack. In artificial neural, as we have discussed, the basic structure of the artificial neural is in layer form: input layer, hidden layer, and output layer. So first we have to make the model in sequential manner. Afterwards, we provide the input and hidden layer. In first layer, already discussed, 64 neurons each connected to all input features in which input dimension which are connected with the, because our input is scalar in x, so we are connected with each neurons with the input parameters, so automatically say number of input equal to the number of features. Or here we are using the ReLU function rectify linear units to introduce the non-linearity and allow the network to learn complex pattern. If for regression kind of problem, we are mostly we are using the ReLU. In second hidden layer, we add the second hidden layer with 32 neurons. Right now, I am adding this 32, 64, and 16. Already, I have done some. I have performed the artificial neural by using these data. You can check, or you can perform, or you can modify these values by putting your data. This is not the exact way, or this is not the correct term. You are going to, you have to modify your model by according to your data set. So for my data set, once I have optimized this data set, my results are results are obtained on with this data set. But whenever you are performing with your data set, you can change it according to your data. So you can vary the number of neurons, or if you want to reduce the hidden layer, or you can reduce the hidden layer in two, or you can put only, you can take, you can keep only two hidden layers, you can keep only one hidden layer, or you can increase hidden layer also. So that will also depends upon uh, your data set. Means what is your problem, according to that you have to decide this model. But my data set, or for the understanding this artificial neural net, I am going with this only. So I add second hidden layer with 32 neurons. Again, I have add activation as ReLU for numerosity. Deepen network improve. Why? The number of hidden layers we are using. So deepen network improve ability to capture the relationship in data. Sometimes it is better to keep the more number of hidden layers. Sometimes it overfit. So we have to be taken to the consideration. That's why dropout is used, that randomly turn of 20% neurons during the training. So which will also used to prevent from overfitting. So third hidden layer adds a third hidden layers with 16 neurons smaller layer, optional. As I said, if you want to keep it, you can keep. If otherwise, you can remove it. Further refine it also for the learn representation if needed. Can be skipped if data set is small to avoid. If your data set is too small, you can remove it. Or if your data set is large, so you can add more number of hidden layers. Now output weight, output layer. In output layer, we have only response, which is yield strength. So we add the output layer for a single neuron, and in that we need a linear, because that yield strength is linear. So directly output a continuous value, no transformation. There is no transformation required. Best for regression problems. As we are dealing with predicting the yield tensile strength, so we have formulated output layer. Now we need to compile the model. So this prepare the network for training. You must compile before calling fit, means before fitting the model, we have to compile it. To compile it, during the compiler we need the optimizer, which is Atom. Already we have used to evaluate the loss function. We have already seen Atom is used for optimizer. Specify optimization algorithm used to adjust weight during the time. So what is the purpose of this optimizer? This is this will adjust weights according to the training. If there is the difference between the actual and predicted value, so during the back propagation, it will adjust the weights after each set of processing. So adaptive moment estimation is very popular because it combines the benefits of momentum and adaptive learning rates, faster convergence and stable training. So, and for the loss function, we are using mean square error term to minimize during the training. Or for matrices, mean absolute error we have used for matrices. So we will put into the code. Now we will run it. Compile. Okay. So now model has been compiled. Now we will fit our model. So you can see here history model fit starts training the ANN. The model has been formulated. Now it's time to train the model using the training data set. Already 80-20 we have split our data set into 80-20 ratio. So by using the 80% data set we will fit our model or we will train our model. So results which is used for history stores we store our results into the string, stores training logs, those and metric values per epoch you can later use for plot learning rate. Why we are using it? Because as we have used matplotlib, I want to show you the how our validation or our training process will take place by convergence plot. So for that I store this training data set into our stream. Xtrain, Ytrain already discussed the split of our training data set in X and Y. X for input features and Y for target value or responses or yield distance. Here in our program for yield distance. EPO we have identified EPO. If you the larger number of data, you can go with the 1,000 data set. But here our data set is up to 43 number of sets of experiments. So I am using only 200 EPO. What is the EPO? EPO one full pass through entire training data set. So setting 200 means model will repeat 200 times to improve the accuracy. Means 200 times is need it to check every time it check the error term and it modify the weight and again with new weight it again run throughout the model and check the error. If error is reduced, then again it will go through the model and adjust the weight. So simultaneously it will work over the 200 times. So too few if we put too few epoch, in that case underfitting, or if we choose too many epoch, this will also go for overfitting. So we have to check this echo value also. So when you are performing your the artificial neural network, so you need to be choose echo in such a way that so your model will not be underfitted or overfitted. Okay. Now base set. Instead of updating weights after seeing the whole dataset, model update after every 8 samples. Like I said, like after each base set means weight has been updated each and every time. So we need to be cautious about that. Instead of, because if we update the weight, so it will take little bit more time. So we need to be adjust in such a way that so time will also be for the our model compilation. Our time will also be not in such a way that so that our we are using more time. So small base time, more updates, smoother learning, but be slower. Validation split. We already split our dataset into testing and training, and in our discussion we have seen like we can split our dataset into training, testing and validation. So for here we have split our training dataset in for validation also. So 10% our training dataset converts into the validation split and set is asset for validation. Why we are doing this? Because doing this, we can monitor overfitting by comparing training versus validation loss. Verbose one, this is used to control the training output display. Verbose is provided print progress bar and matrices after echo, helpful to track model behavior. Like means it is check the model how the our model have behaved. So first we will put. Now you can see that it automatically suggests us the value. So in the PPT I have shown you, in which I have using, we can also take the equal less than 2000, sorry 200, or validation split in zero point 0.2. We can go with that also. Like if I want equal for validation 0.2. Okay, fine. So now you can see here our loss function which is going to be reduced. See, each epo, during each epo, loss value will be, has been updated, mean absolute error, validation loss or validation mean absolute error. So to check how this behave throughout this epo value. So for that we will plot this history. If you want to see the figure, model loss during the training, so we can see this. We can plot it over here. So size of that figure we can put like you know, now we will plot history which is low history. You can see here this is also suggesting us No. Now what we can put over the level for history, that is training. This comes under training loss. And if you want to show, that is MSC, mean square error term. Okay. Now we will plot history. Again, validation loss, label validation loss. There is no need because already we have discussed validation loss. Now plot history, history validation loss, and now plot title. We can also show plot dot title. We can put that title here, that is between model loss during training, because this is before the testing. So training plot. Now what is our X level, that is hippo. Y level should be loss, lesion, or no. If we want to show the grid, so we can show the grid by two. Okay, fine. Plot. Again, if you want to save, if we want to save this plot on our Google Drive, so we can save it by simply writing save figure. Or you can set DPI by your own. Here I am going for 600 DPI. Now dot Kodak. We are importing drive mount content. Again, you can put model loss per content by drive, and afterwards you can name it like model loss curve. This is for FDV lab. Okay, okay, fine. See, here, this is the model loss during the training. Now, we can see that training loss which is converts over the within the approx less than 40 epoch. Afterwards, there are some fluctuation in the valid training, but the values of the loss is reduced less than zero point 0.1. The loss has been reduced after the 40. We can say that less than 40 po, the loss has been reduced up to zero point 0.1. And for the validation, this is also it is reduced, or up, uh, it is near to be zero after the or in between 40 to 50 epoch. If we change here to see it, like if I for better representation, I can change it now. Once I do this, you can see. See, and this will be the curve. Like the repo already has been reduced, so this is this is the overfitting of the curve. As you see, if we increase the number of repo, earlier it was 100, but once we have increased it, so the model has been overfitted the data. So we need to be put in such a way that the repo will not be, or model will not be overfitted. Now, next thing which we can perform, that is prediction. This is already overfitted, so again we need to be modify here. Like if we want to adjust, we compile, we perform the model fit, and afterwards we will plot this graph. But before that, we need to predict. We will predict. So we need to check the R square value to check the determinants, coefficient of determinants of this model. Why predict well, model predict test. What is the line? Why invest of why ठीक okay. Test originally we have to, why we are using inverse transform, because earlier our data we already converted into the normalization. So again we need to be normalize this normalized data, we need to be converted into the actual values. That's why we are predicting the these values we are going to be changed again to its normal value. Now we will calculate the r score, or R square is y predicted term divided by numpy. So for mathematical, we are using the numpy value y to numpy mean by 2. Or if we want to see the R square value, so we can see here, we can print R squared square. That is no. By doing this, you can see NP is not defined. NP dot mean NP numpy. Already we have to show. So we have not used numpy. Okay, so NP is not defined. So we can see here we have not import numpy as NP. Also, partner matplot already we have imported. Okay, fine. So now it is we directly use. That's why split ratio optimizer. Now this one. This is print is not defined. Print. Okay. We directly put R square on. If we want to see R square, so R square, we can see here the value of R square 0.49. So this is the value which is calculated upon the model which is performed. So this value is very low because this is based on the testing, means the 20% value which are tested over the 80%. So model is trained by using the 80%, which is validated by 10% and afterwards tested with the 20% data. So on behalf of that, this model is the coefficient of determination is 49%. So this can be increased, or this will be increased by improving or by adjusting the our hidden layer. We can modify the hidden layers, we can modify the neurons, we can modify the this hippo or base size or validation split by using by making the changes in this term. we can improve the name. Now I want to show you how to predict, like for this data set we already see this is the 43 data set, this is the actual value. Now I want to see what is the predicted value of yield strength, or I want to export this export all these data set into the Excel file. So for this I can write the code so that each data set will be directly imported into the there's so that's why I'm going to use this code. I already written the code, so I am using this code and here. The small change in this code is that in our data set we are using yield tensile strength, or that is written over ultimate tensile strength. So we need to be changed over here. Yield tensile strength. Now you can see that, and we will put it for lab session. Okay. Now this is for you can see here. Earlier the R square value was 49, but in that case the value was is because this is for all the predicted value. Earlier it was predicted for 20% only. Now this is for, because here you can see X all means it is taking not the 20%, it is taking the whole 100% data, means 43 sets of experiment were taken into the consideration. On behalf of that, all the all the responses has been taken into consideration. On behalf of that, all the values in correspondence of x is predicted, and all the predicted value is compared with the actual value of y, and on behalf of that r square value has been determined, which is 0.62%. Still it is very less, because in uh, the value of r square should be more than 85 or 90%. If we need to use the model in further application, so we need to be the value of the r square should be more than 90%. So still it is less, very less than 90, but this can be improved by using this model, by changes in the model, or depending upon the data set, because here I am using three hidden layers instead of three hidden layers, because it is the small data. If this is the small data set, I can remove this, or if you want to remove this hidden layer, you directly put has this has, so this will not considered in the model. Now this line, this is only simple line, this is not a code, this is for a simple line. So by doing this you can change your code or model, and you can evaluate your artificial neural network. So this is the way. Now if you want to see the predicted value of y, so once you run this code, you will get the Excel file here. Now you can see actual versus predicted. Here I have written over here name actual versus predicted FDP lab. So here you can see actual versus, when once I open it here, you can see this is the actual of our data set, and this is the predicted. These are the actual value and on behalf of that, these are the predicted value. Here you can see that these are the actual and these are the predicted. Now, if you want to how the predicted and actual value looks like, or how they are spread to normal distributed curve. So we can plot between the actual versus predicted. So we also can plot this curve for our data set also, which we have gotten. So in our and no, see, this is the graph between actual versus predicted. This line shows the difference between the predicted and actual will be 0, and this is the spreading of actual and by how the actual and predicted value are spreading over this mean line. Okay, so by doing this we generate this simple artificial neural network code for our the simple program, which is based on the friction state process, how the yield distance can be predicted on behalf of the input parameters. So model loss during the training already we have discussed by plotting this graph in model loss during the training, or we can say the convergence. We already see in our plot, we have chosen the epoch, we have chosen the hidden layer in three hidden layers, and number of neurons 64, 32, and 16. And by doing that, preparing the model, we converge the graph. In that graph, blue line, that is we are getting from training loss, and the orange line which is getting from validation loss. Training which is based on 80% data, and validation which is based on 10% data of training. So the blue curve show the training loss decreasing steadily, means model learns patterns, means this is for 200 data, because in for this code actually in our case we are in that in lab session we have used, in that we use 100 epoch. In that also the blue line which is converging below 40, here it is converged below before 25 epoch. In our case it was below 40. So, and the error or the loss is less than 0.1%. 0.1. Here you can see the loss is the training loss decreasing steadily, and it is converging below 25 epoch. And in orange curve, that is for validation loss, which is also check generalization on unseen data. Both curves stabilize near zero. You can see after the 100 epoch, or you can say after the stabilized, or you can say that it is near to 0.0. So it not exact below 0, but it's near to 0. So both curves stabilize near 0 indicates good training without overfitting. In a second case, when we use 200, then you see the data is like you see in our in lab session, when I use 200 epoch, and the validation is 0.2, then we have seen the plot is overfitted. So we need to be decide our epoch value and validation set accordingly, otherwise it will be overfitted. So we need to be taken into consideration when we are performing or when we are doing ANN. Small gap between training and validation load. This is good indicator and healthy model, no high variance. If validation loss started increasing while training, loss kept decreasing, which is also comes under overfitting. Okay, means it is saying like validation load that is seen by orange curve. This is start increasing and our turning loss is kept decreasing. So that would means overfitting. Loss value of education already we have calculate loss value. This is will be the loss value after that 200 depot we can also, if we want to check the loss depot, we can print this loss and mean absolute error by using this simple code execution. R square value in our case that is 0.49 and here it is 0.42. Still it is very less, but we need to be more. We need to be put hidden. We need to be adjusted in such a way that it should be more than 85%. But here we this is between the predicted and true value, which is based upon training set 80% and testing set 20%. On behalf of testing, the R square value is 52. If we want to plot, actually we have already plotted between actual and predicted prediction for all data. Once in this case, you see 72. When we predict for all data, here the R square value is 0.72, and in when we are performing in our case, it is nearby 6.62%. So still, the model is require more modification. Plot for all data, we can plot for actual versus predicted between all plot. This is the actual and predicted data, and this is the mean line through which the mean and the predicted or actual value are scattered through this throughout this mean line. So for the modern better, for the better results, because at the end we want to use this model for further evaluation process. To so for that we have to be modify model in such a way that the R square value should be more than 80% or more than 85%. Better to be 90%, but it should be more than 85%. So for that, first we can modify our model by make the changes in model structure. That is, we can use dropout 0.5. We can use we can vary the number of neurons. If smaller data are available, we can reduce the hidden layer, or if the larger data are available, we can put the more number of hidden layers, and we can adjust the more the neurons. So by doing these things, we can modify the model for better results. So by this way, we can platform. So up to this, we have in this session what we have done. First of all, we have identified or input output response. Afterwards, we have extracted the experiment data. We have already converted 43 experiment data into the normalized set. Afterwards, we range it into 0 to 1, where we have personalized data into training set, testing set, or validation set. And afterwards we have used we already choose number of hidden layers activation function, in which for regression analysis we have performed the regression analysis. So we have choose relu as an activation function. Again, for the hidden layer we define the neurons and selection of training algorithm. Already we define the error goal, which is near to be 0. The error should be as much as uh, minimum as possible. We test or validate our network and model ML model ready for evaluation. So for before the evaluation, we need to be satisfied this condition. Error goal should be attained. Before that, if there is error dot is not attained, we need to be modified our model several times. Once we are satisfied with this error goal, then we can use this model for evaluation. So this is for our lab session. Hope you understand. If you are having any doubts, you can put into the chat box, or you can mail us through this mail, jinesjain.mail @mnit.ac.in, or you can put into the chat box. So once we see, and we will resolve your queries.
Thank you, sir, for the session. Online participant can ask any queries in the chat
So
box.
participants, if you want, you can put your queries into chat box.
Okay. Next, we will start the another lab session at the 4:30 after the short break, tea break. So thank you. Stay tuned. बहुत बढ़िया सर, बहुत बढ़िया लेक्चर्स। अच्छा, हेलो हेलो। हाँ सर, आवाज आ रही है? आवाज आ रही है? हाँ, मैं कह रहा हूँ बहुत बढ़िया सेशन रहा है आपका। और अभी 4:30 बजे से है ना सेशन? मैं तो ऊपर ही बैठा हुआ हूँ जैसे कि। अब बता देना 4:30 है। ये तो 2 से 4 तक का था, अब शायद टी ब्रेक है। हाँ। और